Hello, it is Wednesday, and today we're going to be finding the area of trapezoids, rhombuses, and kites. A trapezoid is a quadrilateral that has one pair of parallel sides. The other two sides across from each other have to not be parallel for it to be a trapezoid. To find the perimeter of a trapezoid, you add up all four of the sides. You do not necessarily add a segment inside here. You just add up all four of the sides. We're going to focus on area, though. The formula for area of a trapezoid, since a trapezoid has two bases, the parallel sides are the bases, so you're always looking for the parallel sides. If you add the two bases up and multiply by the height, and then divide by 2, you get the area of a trapezoid. So you will see the formula like this on the formula chart. A equals, in parentheses, b sub 1 plus b sub 2, base 1 plus base 2, close parentheses, times the height, divided by 2. And sometimes you will see it with a 1/2 in front of this instead of the divided by 2. You can change it to divided by 2 if you like. So let's look at the first example. We're finding area. Again, we're going to write our formula. Then we are going to plug into our formula. So we're going to say area equals. Okay, we have to remember that the bases are the parallel sides, so we have a 14 and an 11 on the parallel sides. So 14 plus 11. The height has to be perpendicular to the bases, to both of them. So we look for our right angles. There they are. So 7 is not the height, but 6.2 is. And then we're going to divide that by 2. And you write it out like this, and when you put it on in the calculator here, you want to be sure that you type it in exactly like that. So you want to do Control Divide and get a fraction. Then you want to do your parentheses, 14 plus 11. And then you can either do parentheses 6.2, or you could just do times 6.2, and it'll put a little dot there. And then over 2. And you get 77.5. Again, because this is area, it's meters. This is meters plus meters. When you add meters, you get meters. But then when you do meters times meters, you get meters squared. But because it is area, it's going to be meters squared. And let's keep in mind that that 2 right there, it goes with that fraction. So we get 77.5 meters squared. You never want to think of the bases of a trapezoid as the top and the bottom, because you'll get one like this where they turn it up on its side. The bases are still the parallel sides, so here's this parallel side to this. We've got a 13.3 here, but right here you're going to have to add those two, the 5 and the 13.9 together to get the entire base, so that's going to be 18.9. And then you plug in. Area is base 1 plus base 2 times the height divided by 2. Write the formula first. Then area equals base 1, I'm going to let be 18.9 plus 13.3. And the height, well, the height's not given this time. The height is this segment right here that is perpendicular to both. So we're going to have to find it because this is a right triangle. If you remember the triple, you'll know that that's 12. But if you don't, you'll have to go 5 squared plus, let's just call it a squared, equals 13 squared. 25 plus a squared equals 169. Subtract 25 from both sides, and you get a squared equals 144. Square root, and a is 12. But again, those of you who remember the triple, you just automatically say, well, that's 12. I don't have to work it out with Pythagorean theorem. So that's times 12, and all of this is over 2. So now you're going to put that into your calculator. So go to your calculator, go to the scratch pad, calculate. I'm going to clear this off again. All right, control divide, and I've got 18.9 in parentheses. So parentheses 18.9 plus 13.3. Make sure I've got this right. And then close, and then times 12 over 2. And I get 193.2. So that's going to be 193.2, and it is in inches squared. Area is always in inches or units squared. Okay. Sometimes they turn them up like this, and this isn't really what you think of maybe when you see a trapezoid, but this is a trapezoid because you have parallel sides and non-parallel sides. The formula is the same. Base 1 plus base 2 times height divided by 2. The thing is, you've got to type in, or you have to add the bases together first before you multiply by the height, because you have to follow order of operations. But if you will type this in the calculator using the control divide and type it in exactly like you see it, you won't have to worry about that. Alright, we plug in. The bases are 17 and 15 because those are the parallel sides. So even though they're not the top and the bottom, that doesn't matter. So you get 17 plus 15. The height is 9 because that segment is perpendicular to the two bases. And then we're going to divide by 2. Move it over. Put the calculator here. Control divide. 17 plus 15. Oh, forgot to put it in parentheses. Go back. Okay. Close. And then I think I'll put the 9 in parentheses this time. Over 2. So you can either hit times 9 or just put it in parentheses. And we get 144. And that, because they did not give me a unit of measure on this one, I can just put units squared. Alright, here's our last trapezoid. It's a trapezoid because I have parallel sides. And I know I have parallel sides because I have the right angles here. So it's going to be A equals base 1 plus base 2 times height over 2. Plug in. The bases are the parallel sides, so that's the 18 and the 15. The height has got to be the one with the right angle, so it's not 10, it's 8. Over 2. Type it into your calculator. Control divide, parentheses, 18 plus 15. If you leave the parentheses off, it will give you an incorrect answer. And then times 8 over 2. And you get 132. Meters squared. Okay, now let's look at kites, rhombuses and kites on the back of this. If you'll turn over. Okay, let's define what a rhombus and a kite is. A rhombus is a quadrilateral where all four sides are the same. And a rhombus is also a parallelogram, so we have two different formulas we can use on a rhombus depending on what information is given, and I'm giving you an example of each one. A kite is a quadrilateral that has two pairs of consecutive sides congruent. So the sides that are congruent are next to each other. Consecutive means one right after another, so the sides are next to each other, the ones that are congruent. A kite is the shape that you think it is. It's if you make a kite, the traditional kite shape, that's exactly what it is, and that's why it's named that. A diagonal in a polygon, since these formulas use a diagonal, then a diagonal is a segment that goes from one vertex to a non-consecutive vertex, which means it doesn't go to one that's right next to it, it goes to one that is not next to it. So the diagonals go across the middle of the polygon for rhombuses and kites. The formula for area is 1/2 times diagonal 1 times diagonal 2. So you take the diagonals and multiply them together, and then multiply that by 1/2 or times 2. We're gonna plug in the formula and put it in the calculator just like it looks. So let's look at the first one. Now this is a rhombus because all 4 sides are marked congruent with 2 marks. But I do not have diagonals drawn. If you look over here, here's diagonals. This is a diagonal, and this is a diagonal, but it's not drawn in the first one. So, because I don't have a diagonal drawn, I'm going to use the formula for a parallelogram and say base times height, and that's going to be 8 is the base, and the height is 6 because of the right angles. So I get 48 units squared, and I'm done with that one. I don't have to use the diagonal. So you have 2 formulas you can use on a kite. You can use the area formula for a parallelogram if you're given the base and the height instead of diagonals. But over here, if you're given diagonals, then you will use this one. It's the area is equal to 1/2 d sub 1 and d sub 2, which is diagonal 1, diagonal 2. Alright, so that's going to be 1/2. Now, it doesn't matter which diagonal comes first, but let's say we take this one. That's going to be 20 plus 20. You got to add those two together to get the big one. Sometimes they'll give you the whole thing, and sometimes they give you the halves. So that's going to be 40. And D2 is 10 plus 10, which is 20. Alright, and then we put this into our calculator. And to put it into the calculator, we're going to do it exactly like it looks. We're going to say, control divide, 1/2, parentheses, 40, parentheses, 20. Now, if you want to not use parentheses and do 1/2 times 40 times 20, that's fine. That'll work. And then you push enter, and you get 400. And that's in units squared. All right, the next 2 are kites. I'll move those up so you can see them. The first one here, I'll zoom in on this. In a kite, that is a right angle. So you have this missing segment here that you need. And you will use Pythagorean theorem to find it, and we'll just say 5 squared plus a squared equals 13 squared. And so again, we've already worked this out, so I'm not going to work it out again. A is going to be 12. We worked it out on the other side because that's a 5, 12, 13 triangle. So this is 12 right here. All right, so here's what we have. We've got 2 diagonals. Let's just say this is D1, diagonal 1. Well, that's going to be 5 plus 12, which is 17. Now, diagonal 2 is going to be 5 plus 5. And by the way, in a kite, and we will talk more about kites later on, but in a kite, you have one diagonal that bisects the other diagonal, so this diagonal has congruent segments and always will. So you get 5 plus 5 is equal to 10. Your area formula is 1/2 times D1, D sub 1 times D sub 2. Okay, we plug in 1/2 D sub 1 is 17, and D sub 2 is I wrote 2. Wow, it's just like I'm here. I wrote 2, but what I meant to write was 10. Easy fix. So we type that in. 1/2, control divide 1 over 2. Let's see, 17, parentheses, in parentheses, and then parentheses 10. And we get 85. Right. Again, they did not use units in the problem. I'm not going to count off if you don't use units in your answer. but if you want to always just be in the habit of doing that, just use a U for units. Alright, here's the last one for kites. Area formula is going to be 1/2 D1 D2. Okay, plug in 1/2. Okay, D sub 1, again it doesn't matter, I'm going to let 8 be D sub 1. Okay. 21 for D sub 2. We type it in. So 1/2. Parentheses 8. Parentheses 21. Enter. And you get 84. The unit on these links is yards, and you'll notice on this one it shows you that that's the whole thing because they show you this segment up here. So you need to get used to what that looks like. Sometimes they'll put marks like this and this at the end of those, but that is saying that this length is for the entire diagonal. So because it's in yards, we'll get yards squared. Alright, that ends the notes over area of trapezoids, rhombuses, and kites. You are now ready to raise your hand, show Miss Kennedy your notes, that you have completed your notes, and then she will give you the assignment to work on. And when you are finished with that, please turn that in. And I will be back tomorrow with more notes and another assignment for you to work on. Goodbye.